All right. Good night. And again, doing this paper for Jordan in Tobago. What I find is that when I give the answers to these questions, persons prefer to actually see the work now rather than just look at the answers. I even just look at the solution in writing. So yeah, so this is another pure maths paper, unit 1. This is the June 2020 paper 1, and Jordan asked me to do this paper. All right, so I'm also going to put it on my channel so other persons can benefit. And if you like the content of the channel so far, in particular with the math, then you can share the channel and subscribe for each time, so that each time a video is posted, you will be aware. You can hit the notification bell, and you can give comments. Give comments as to what you want to see, and how I can present the math in a way that is more friendly to you guys, whoever is viewing these videos. All right, this is just me sharing share my knowledge. All right, and yeah, it's just fun for me to do. It's one of my hobbies, so I'll continue to do it. So from time to time, I'll be posting videos. It's actually midnight now. Right? Midnight. See? Midnight. I'm just basically taking time to just record this. All right, for the benefit of whosoever is doing the subject, whoever is doing the subject. All right, so let's go. Let's see how quickly we can get through this. All right. So as I said, this is a June 2020 COVID year exam paper. All right, first question, number 1. It says, in the real number system, the inverse of addition is represented by what? So how one operation works is that when you carry out the operation on an element and its inverse, the result is the identity of that operation. We're talking about operation of addition. The identity of addition is 0, and the inverse of a value under addition is the negative of the value. And so basically we're talking about these two. Right? So the operation is to add, and they are inverse of each other. And when you carry the operation and those two inverse values, you get the identity of the operation, which is 0. The identity element for addition of real numbers is 0. So basically, this is the answer for this question. This is it. All right. Next question. Number 2. Gives us this function. This equation, sorry, it's activity equation. It says f of s is equal to 0 and f of minus r is equal to 0. It therefore means that s is a root and negative r is a root. So s is a root, s, and minus r are roots. They are roots of the equation. And if you know the root, then you also know factors. So since this s is a root, it means that x minus s is a factor. And from this one, it means that x plus r is a factor. So these are factors. These are factors of the expression. Simple as that. Right? By the factor theorem, if a is a root, then x minus a is a factor. Right? So you're looking for in the factor form, you're looking for these expressions in the factor form down here. Right? Those would be 2 factors in the expression. All right, so we say x minus s, we say x plus r there. If you notice, you don't have that anywhere else, right? When you have, for example, next one where you have x minus r, x minus s here, you have x minus r, which is wrong. Right? The correct answer is A. This factor, basically, you know, it's ax because of this value. That's a x cubed, ax cubed, right? So what happens is that these three will multiply to give you that one. That's why it has to be ax, right? And then the p now would just be such that that p, that r, and that minus s, they will multiply to give you that e, all right? But we're really interested in the first two factors, which makes E the answer. Number 3, it says P, Q, and R are propositions, and they are such that P is a statement, it is raining. Q is the statement or the proposition, the sun is shining, and R is there is a rainbow. It says the expression, and they're going to give us this expression now that is in quotes. We have to basically use these, right, and the connectives to say which of these is correct for that statement. It says, it is raining. So it is raining is P. And it's conjunction and the sun is shining. So that's P and Q. P and Q. But here is now taken to mean and as well. So that's it. And there is no rainbow. So this R is rainbow. So no rainbow means not R. Not R. So you have this and this. Then the but means and again, and not R. So that's what you're looking for. So P and Q and not R. P and Q and not R. So the answer is this one. P and Q and R and not R. So but really means and in this case. All right? But really means and. All right. Next one. Gives us this expression, and I want us to find the value of x. So it gives us this log equation, and we have to find the value of x. What is x equal to? All right. So since it's a logs question, logs usually can be wrote out in many different ways. Here we're also going to use the basic laws of logs. So we're going to add these two. We add these two logs to become the log of this product. And when you subtract this log, it means that you're taking the quotient. All right. So we're going to put it all together. So the expression becomes log, that becomes log to base a, multiply the 4 and the x, we get 4x. Because of this minus, we're dividing the 7, divided by 7, and that is equal to the right side now, which is 2. So this, all of this becomes that. I'm trying to find x, you know. So this is our number, and so it is equal to this base raised to the 4. Right? So it means that the 4x minus 4x over 7 is now equal to a squared. Because this is a base raised to the power 2 by the laws of logs. If we try to make x a subject, now we're going to multiply the 7, get 7 a squared and divide under 4. And so that is x 7a squared over 4, which is 7 over 4 a squared. All right, that finishes that one. Number 5. Number 5. So for this one, gives us this expression, and it is equal to one of these. And as I observe these answers, I see root x. So it means that I don't want this 3 on the x there. So I'm going to break it up. So this x, this basically becomes, let me zoom up on it a bit. It basically becomes 4 root x plus 4. I'm going to break this up now, and I'm going to put root 3 root x divided by this 48. I would love to get a root 3 out of it. I'm going to write that the square root of 3 times 16. 3 times 16. That's 48. Because I'm trying to get the root 3. Cancel with this one. But then this is root 16. Root 16 is 4. So it really becomes equal to 4 root x plus 4 root 3 root x over the square root of this 16 is 4. And we are left with that root 3 times root x. Well, that's not no, that's it. And so these cancel. This cancels with that. And we then have 4 root x plus root x, which then is 5 root x. The answer is 5 root x, which is the answer right here. 5 root x. Number 6. This one says, given that x and y are negative numbers, and that x is greater than y, which of the following is true? So this can be done quickly by an example. It can be done by a calculation method, but also can be done by example. So what I would do is to actually give values to decide which of these is correct. This is the answer. If I look at it, I can see that. But let me show you now. So I have x is greater than y. So if I were to put a number line quickly, and I put -2 here and -3 here, that's how they would appear on the number line, right? The values increase that way, but the sign is negative. So this one is actually smaller than this. So this would be our y, and this would be our x in this example, right? Such that the x is greater than y. Now, the y squared, right? The y squared would therefore be equal to 9, and the x squared would be equal to 4. So when you square the values, the inequality sign is going this way. 9 is greater than 4, right? Which then means, which is the same as x is less than 9. X is less than 9, right? So we end up having that y squared is greater than x squared, which is the same as x squared is less than y squared. That's one way to do it. Just use actual values and sort of, let's use some values and test it and see which one is true. But it also can be done by calculation. And if you look at another video on the channel for, I think, June 2021, choice, there's a question, this exact question there. And I use another method to do it. So you can search for that video on the channel, June 2021 solutions, people 1, 3 months. All right. This question, we have to solve this. Now, when you're solving a modulus inequality, when you have modulus expressions on both sides, method to solve it is to square both sides, expand and solve. There's no shortcut, right? You have to square both sides, expand and solve. When you have modulus on both sides of an inequality, you square both sides. There's no shortcut method, right? So when I square both sides, so this expression, go back for the blue. So this expression is going to become 2x minus a squared greater than x squared. And that's what we're solving. Becomes an inequality. This side, we're going to expand out this side, we're going to get 4x squared. Plus the product of the two give me minus 4ax plus a squared. And that is greater than x squared. Transpose over this side, I get 3x squared minus 4ax plus a squared greater than 0. That's a smile, we're going to be outside the two roots. But what are the two roots? We're going to factorize this. All right, it's going to be a over 3 and a really. Right? So we're going to get 3x here, x here, a here, a here. Signs are the same, they are both negative. The two signs are negative, 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 greater than 0. So those are our tools. Now this will be related to a smile function. So if we do a sketch of that function, this is the x-axis. Based on this factor, root from that would be a third A. And this factor, it will be A. So I am going to put A right here and a third A right here, 1/3 A, or A over 3 right here, A over 3. And this means that we want above the axis, we want the part of the graph that goes above the axis here and up here. We'll put back that total circle. We're not including them, that's why I'm putting the unshaded circle here. All right, now this is obtained by values to the right of A, so that's x has to be greater than A. This one is values to the left of A, which means that we want x to be less than A over 3. All right, and basically that answer is A up here, right here. That answer right here. All right, nice and easy. Nice and easy. Number 8. Less than A over 8, greater than A. Number 8 next. All right, so this one says, give us this polynomial. It's a quadratic actually, quadratic. And it says P of A is equal to 0. If P of A is equal to 0, it's basically saying A is a root. Not A, this is alpha. Alpha is a root. It says what is the value of H in terms of alpha? So we're trying to find H. So basically, if P of A equals 0, then we can substitute the A in there for the X and then put the expression equals 0. All right, so based on that, this becomes not A, no, it's alpha. It becomes alpha squared minus H alpha minus 12H squared equals 0. And the thing about it now is that we're trying to find H. This H we're trying to find in terms of alpha. So therefore, we're solving for H. And H now, if you look at the equation as H as a variable that we're trying to find, it's really a quadratic. So I'm going to solve for H and treat it as a quadratic in H. Right? So let's rewrite them with the square term positive. So I'm going to multiply 2 by -1. It's always easier when the square term is positive in quadratics. I'm going to multiply by -1. So this term becomes 12H squared. And then this becomes a positive plus, I'm going to write alpha H instead, because H is now my variable. And then I'm subtracting alpha squared. And this is equal to 0. And that's what I'm solving now. Solving for H. Now, can I factorize this? These and these answers I'm sure this can be factorized. So let's factorize it. I could use a quadratic formula. Let's factorize it. The factors of this must be alpha and alpha alone, alpha and alpha. Factors of this now, based on these numbers that I'm seeing, is about 3 and 4. So I'm saying 3H and 4H. Two signs in the bracket are different. This tells me that I get the greater product, the positive sign. This product is 3 times 3 alpha H, and this product is 4 alpha H. So this one is a greater one in there. I want to make it positive by putting a plus here, minus here. This is equal to 0. If I make H a subject of this, then I'm getting H equals minus alpha over 3. And this one is giving me H equals alpha over 4. So minus alpha over 3, alpha over 4, the answer is A. This one. All right, is that number 9. This question says, if the range of this function is this, what is the domain? So remember, the domain, let's zoom up on it. The domain really are your x values now. The domain are your x values. Right? And these are your range values. These are these. Now we're really trying to find domain. So what it makes sense to do is make x the subject of this, because we can plug these range values into the function and then find out what x is. So we can make extra bit of it to find them quicker. Right? So basically it's almost like we're taking the inverse. I'm going to make extra bit of this function. Right? So let's call this y. Let's just call this y. And these are y values. I'm going to call these y. Let's keep it simple. Call these values y. Right? So I'm going to care about the 1 first. I'm going to get y minus 1 equals over x. You have to take the reciprocal of both sides, or I can say multiply the x and divide under the y minus 1. So x becomes 2 over y minus 1. And then now it's a matter of plugging these values into that for the y and see what the x is and see which of these values correspond. Right? Which of these answers correspond. All right. So if I plug in there, I'm going to plug in these 3 values first and see if we can pick it up what the answer is, because I'm going to use a process of elimination. All right. So I'm going to plug in the 2 first. So I plug in the 2, right? It's y equals 2. So y equals 2. The x becomes 2 on the zoom it out. So x becomes 2 over 2 minus 1, which is 2. So 2 is in there. X equals 2 is in the domain. So all the ones with let me see, all of them have 2 in it. So you have not eliminated any. But 2 is in all of them, right? So far no luck. All right, let's try 3 now. Y equals 3. Y equals 3. What do we get from y equals 3? Let's see if we can eliminate anything. Leaving the fraction for last. X becomes 2 over 3 now minus 1. This becomes 2 over 2. 2 over 2 is 1. So this equals 1. So the one without a 1 in it is not. So this don't have a 1 in it, so that is not it. All right. And so we know again I have 3 to choose from. That has a 1. That has a 1. This has a 1. That there's no escape. We're gonna have to do all of them, apparently. I'm gonna put in the 3 next, the 5 next. All right. I'm gonna go y equals 5. The x becomes 2 over 5 minus 1. And that's 4. So 2 of 4 is a half. We're looking for a half now. So half is in this, and half is in this. All right. So either this one or this one now to complete it. Because we can eliminate this last one. So you see, we end up with all of them. All right. Now this 3 over 2, if you like, we can just put it as 1.5. 1.5. All right. So I'm going to put y equals 1.5 instead. Right, because this is just 0.25 and this is 4. So y equals 1.5. The x becomes 2 over 1.5 minus 1, which becomes 2 over 0.5. And to divide by a half is to multiply by 2. So this equals 4. So it is 1 with the 4. So this is wrong. So it is 1 with the 4. So yeah, we ended up have to work all of them. You know. And the funny thing about it, you know, if you had used a fraction first, would have got that answer, you know, the 4. It's all over with that 4. So you see why sometimes we must run away from what we think is, you know, more work, right? It's not really more work still, but you know, realize if you have just done it in the order there, would have gotten to our answer right away. But that is the only one with a 4, right? So if we had done this first, would have gotten the 4. 2 over half is a 4, and then we would have just mark this as the answer. All right, what's it go? All right. Next one. This one says sum of the squares of the equation, sum of the squares of this, sum of the squares of the root, the sum of the squares of the root. All right, so we call the roots alpha, beta, gamma. All right, so alpha, beta, and right either that, so that's the lambda, no matter. What sum of the squares? What are they asking us for? They're asking us for alpha squared plus beta squared plus lambda squared. Now, this is equal to the sum of the roots, alpha plus beta plus gamma all squared minus 2 times the product of the roots pairwise. Let me put it under here. Let me put it under here. Running out of space. So this becomes equal to that. That's the sum of the square roots equal sum of the roots squared minus the pairwise product, which is alpha beta alpha lambda plus beta lambda. So the question is what is the sum of the roots? Sum of the roots is minus b over a. I'm gonna put minus 3 over 4 squared minus 2 times, what's the pairwise product? Pairwise product is c over a. The a is 4, c over a. So that becomes minus 2 over 4. Let's work out now. This is 9 over 16. 9 over 16 plus this minus becomes a plus. This actually becomes 1, but 1 is the same as 16 over 16. So the final result here is 25 over 16. So it becomes 25 over 16. Right, this answer is right here. That's it. Right, so this is something that is good to know. Right? You should know from ADMATS, similar to ADMATS. Remember in ADMATS, alpha squared plus beta squared was alpha plus beta r squared minus 2 alpha beta to alpha beta. It's basically the same thing. Right? Basically we use the pairwise product. Right? That is it. So we make that connection. Right, next question. Number 11. Number 11 says, which of these is true? Now, if I get these and I can't really interpret them, right? I can just give a couple values, right? Just from maybe 1 to 2, the first 2 values, the first 3 values on either side, you know. So I'm gonna say if I put in the values for the first 3 here, it's gonna be 1 squared plus 2 squared plus 3 squared. And is it equal to this? What is that? That is 2 times the sum of r becomes 1 plus 2 plus 3. That's not equal. This becomes 2 times 6 is 12. And this can't pass 12 long time. So you can put across this equal sign. Right? So it means that that one is not correct. Cross that equal sign. So put X on the first one. Not correct. The second one, this is assuming you don't know the answer is the last one. Because I looked at it, if you break this out, you're going to get 2n. And then this now is this. You can break it up. So I look at it, I could see that. Right? But let's go through now each one still and show you how you could just, just test a couple values and see. So if I'm doing this now again, it will be the same as this. Right here. 1 squared plus 2 squared plus 3 squared. This is 9 and 1, 10 and 4, 14, right? What is this side equal? It will be equal to 1, 2, 3, 1, 2, 3, 1, 2, 3, 1 plus 2 plus 3, all squared. Sum of r all squared. Again, they're not equal. And this is 9 squared, which is 81. And this is 14. Right? So again, this is not equal. So that also is not the answer. And then this one now, this is kind of ambiguous. I think this minus 1 is not under the summation. If they want to be under summation, they would have to put a bracket around it. So I'm going to assume that it is this. plus 1. Sum of r squared plus 1. All right, this one starts at 1, this one starts at 0. So let's see. So the left side again, the left side again would be 1 squared plus 2 squared plus 3 squared. And we're saying that to be equal to what is in red would now be 0 squared plus 1 squared plus 2 squared. Plus, no, not plus, minus 1. Subtract 1. Again, not equal, none at all. All right, they don't come out to the same, so that's not equal. So the answer must be the last one, you know. Inside the last one, can you try to mark it? Answer is the last one right there. How we come to be that? Because this summation can be broken out into the sum of 2 plus the sum of r squared. So it becomes the sum of 2 plus the sum of r squared from 1 to n, 1 to n. Now the sum of 2 from 1 to n really is like 2 plus 2 plus 2 plus 2 plus 2 plus 2 n times. Right? So it's n times 2. So this actually becomes 2n. And if you notice, they did not expand that, they leave that. So this side comes back the same. Sum from 1 to n of r squared. That is why this is the answer right there. Right? Number 12. Number 12 says, which are the following are factors of this? Remember, if it's a factor, it means that in this case, f of minus 1 will be equal to 0 if it's a factor. So I'm going to say which one of them give us 0. All right? Which one of them give us 0. So which of these now lead to remainder of 0. So when we work out for this one, we're working out f of minus 1. All right? Because it's f of minus 1. Because if you divide as x plus 1, it's the same as x minus negative 1. Right? So this is a right there. All right? In the factor theorem, it says if x minus a is a factor, then f of a equals 0. Right? So a in this case will be negative 1. So plug in negative 1 here. So a negative 1, when a negative number is raised to an even power, it becomes positive. So this becomes positive 1 times 4 is 4. Plus, this becomes not plus, this becomes negative now. Because you're cubing the negative 1, so it becomes negative 8. And then this is a square again, and so this remains a positive 2, but then it's being subtracted, so we're minus 2. And then now the negative 1 and this going to render is positive, so I'm going to get plus 6 minus 4. How does this work out? Now, this wipe out this extra amount. Now you can use the calculator. This wipe out this. It's going to equal 0 now. Nope, that not equal 0. Right. So if that not equal 0 is not a factor. So find it already, first one. So this is not equal to 0. Not equal to 0. Therefore, x minus 1 is not a factor. So check the following factors. So this is not a factor. So because that is not a factor. Not a factor. 1 is not a factor. Okay, x so this, so that, x so that. The answer must be the second. We don't go any further. So the first one is not a factor, and then list the first one in those 3 answers. And so it has to be the second two. That's only answer. Everything with the 1. The first one is out. And they put the first one in 3 of the answers. So that eliminates those 3. Quick and fast. It was like a gift. All right. Let's just double check it. Minus 8, minus 2, plus 6, minus 4. All right. And I said this wipe out that. And this is actually negative 10. All right. So this is correct. All right. Next question, number 15. Rules of the cubic equation are this and this. And they're asking us for the third root. Now to get the third root, what we can do is search for the factors. Search for the factors in this. Because this would give us two other factors before. So if this is a root, then x plus 1 is a factor. So this equation would become x plus 1. And if this is a root, then x plus 2 is also a factor. X plus 2. And then it's a matter of working out the third factor based on the values. So it's x times x. You need a 2x here because this is 2x cubed now. So you need a 2x here. Remember, it is these first three values you multiply to get the first value in the expansion, the expanded form, right? Then now the focus is more on the last value because it is this value, and this value. Trying to figure that value that gives it a negative 6. So what it is that 1 times 2 is 2. To get negative 6, you need a negative 3 over here. So that is your third factor. It's equal to 0. So this is your third factor. That factor is going to give us a root. This is a factor, right? It's going to give us a root, which is 3 over 2. As I can put this equals 0. All right, it's going to give us a root, which is 3 over 2. Answer is right here. All right, number 14. Coming up to 1/3. Well, yeah, 1/3 way. It says that expression expressed as a single log in simplest form is what? All right, so we want to express it as a single log. All right, so you see this one, we will change it into logs, working in base 2. So the 1 is same as log to base 2 of 2. Anyway, laws of log, these things become very easy. So I'm going to bring this 3 up here as a power. Remember, it's on the power of everything. Bring this 2 up here as well. So let me write what is going to become. So the expression here is going to become log to base 2 of 2q all cubed minus this 2 going up here again. So it is log to base 2 of 3q all squared. And then this one is the same as plus log to base 2 of 2. But this is equal to 1. This is equal to 1. We'll put it, this is equal to 1. All right. And then now when you subtract, you divide the number. So it becomes log to base 2 of, well, this expands out into 8q cube over, this expands out into 9q squared. Right, and then now we're adding this one. So add that one now, we are also to multiply so by the 2. By the 2. So that's how we get the log of that one expression. And so this is a matter of simplifying this down, right? 8 times 2 is 16. So it becomes log to base 2. And then out of the q's, one of them is cancelled. Q squared is cancelled. I'm going to get 16q over 9. 16q over 9. First one. Right here. All right, so number 15, guys. Remember, I'm saying that if you hear me still watching the video, then it means that you see some value in it. So give a like, kind of like, and if you want to see future content, you can subscribe and hit the notification bell and leave a comment, and also share it with your friends. Share it with people who benefit from it. All right. What is this expression logically equivalent to? Which one of these? All right. So this kind of follow almost like the BODMAS system. So you can distribute the OR over the AND. When you distribute the OR over the AND, treat this out here as you would do with a multiply. Treat this inside here as you would do with a plus. And I'm going to work out what is inside this first. Right? Leave the not outside for last. Leave that not for last. So it's going to become this now. I'm going to leave this outside and work out what is in the bracket here first. I'm going to distribute the P using the R over the bracket with the and. So like the distributive law inside there. So I'm going to get the not. And then inside here now, I'm going to distribute the P. It's like P times not P. So you get P or not P. And then they get the plus like an and, but the plus is a and enough. So and you're gonna get P or Q. P or Q. Right? And all that is inside the bracket under this now. Let me change this to red. So it will stand out. And you're gonna distribute R over red. But you see this? P or not P. P or not P is one of those things that you must know. P or not P must be true. P and not P before us. It is impossible for something to be and not be at the same time. But something is either being or not being. So P or not P is true. So this statement is true. So I'm going to put that. I'm going to put the not. Put back this bracket, this red bracket. This becomes true. P or not P is true. Always true. That's what we call a tautology. You know, contradiction and tautology. Always true. And P or Q. What it is now, I have realized now that true and whatever this is becomes that same thing. Because look, if this is a true, then true and true is true. So the result is whatever this is. And then true and if this is a false, true and false will be false. So again, the result of inside here is whatever this is. So I can just write that. All right. So this becomes not. I'm going to put back that bracket in red. Then I call this algebra, propositional algebra, something like that. Algebra proposition. I would say it becomes just P or Q. And when we distribute the not over the R, it reverses that R and makes it into an and. We're going to negate the P, we get the not P. We distribute the not over the R, becomes an and. We distribute this over the Q, we get not Q. This is the answer. Not P and not Q, which is the last one. All right, number 16. A circle is defined as this. The gradient of the normal at this point, 0, 0 now. Where's the center? The center point would be -2. From this, there's no value on there, that's the y square, so -2, 0. And you want the normal. So remember, the normal will pass through these 2 points, you know. The normal will pass through those 2 points. The normal pass through the center and the point, right? On the circumference, right? This is normal passing through those 2 points. Realize that at those 2 points, the y-value is the same. Once you have 2 points on the line with the y-value is the same, means that the equation is y equals that line. Simple as that. Because this will be on the x-axis and this will also be on the x-axis, 0, -2. So that line is y equals 0. The x-axis is y-axis, sorry, y-axis. So this is the y-axis. This is the gradient. This is the y-axis, right? So this is the y-axis, y equals 0. So the normal is -2, 0. Let me draw it just to make sure. So the y is 0. It says y equals 0, which is the x-axis. Sorry, y equals 0. Y equals 0, which is the x-axis. Right? So it's like you have the 2 points, -2, 0 on the x-axis, out here, and the other origin here, so 0, 0. So this is the x-axis, y equals 0, which is the x-axis. I'm shift this over and leave it. Right, just to show it work. This is the x-axis. And the gradient of a horizontal line, the gradient of a horizontal line is 0. So then say 0. Gradient is 0 on a horizontal line. Gradient is 0. Or you could calculate the gradient between these 2 points. Difference in y or difference in x. So the difference in y, this minus this is going to give you 0 in numerator anyway. So you could also calculate the gradient is 0. Right? If the normal was the y-axis, then the gradient will be infinity. Or any vertical line for that matter, gradient is infinity. It's infinity, right? You mean undefined. Right, number 17. This now is the sum of two sines. Sum of two sines is sine cos. And again, in that video that I did 2021, I did a question where I wrote out all those factor formulae in it and explained it. Well, this one is going to become twice the sine of half the sum times the cos of half the difference. Twice the sine of half the sum, 6a plus 4a over 2 sine cos, and the cos of half the difference, 6a minus 4a over 2. So it becomes twice sine. This becomes 10 over 2, which is 5a, cos, it becomes 2a over 2, which is just a. And that is the last one right here. Number 17, number 18 now. Number 18 says, give us this, and want us to know the minimum value. That is the sum of sine and cos. So remember now, this can be written in the form r sine theta minus alpha. Right? So the r is the square root of the 8 squared plus 5 squared. Right? And the alpha is tan to the minus 1 of p over a. So this becomes your b, this becomes the a, this becomes the b. A equals 8, b equals 5. So tan to the minus 1 of b over a becomes tan to the minus 1 of 5 over 5 over 8. But you don't need this, this angle. Right? This function is maximum when r is maximum. The maximum value is r when this is equal to 1. Remember, the sine function can be more than 1, can be less than 1. And the lowest value can be is -1. So the maximum value is minus r. The minimum value, sorry, is minus r. So the minimum is equal to minus r, which is basically minus this. Minus square root of 8 squared plus 5 squared. What I wrote down to, that must be, let's do the calculator, 8 squared plus 5 squared. Let's see what the calculator gives me. 8 squared plus 5 squared, square root. Okay, screen. Square root of 8 squared plus 5 squared. I'm gonna get 9 point something something there. Put that answer right there. Let me see minimum value. Let me see. or the square root of 89, the minus negative square root of 89 or negative square root of 89. It becomes square root of 89. Yeah, because it's 64 and 25. Wow. Square root of 89, negative square root of 89. Okay. Who is the character for that, man? That's 64 and 25. 64 and 25, 89. It's something around to the character and don't even need it. This one says relationship between the curve and the line is that. And here now they're talking about the nature of the root. So it's like you're trying to solve them simultaneously. And then now you want to see if the lines that tangent to the curve, it means that the quadratic equation that you get, when you're trying to put them together, will have equal roots. And so, but let's get the equation first. So at the point of intersection, this becomes equal to that, right? So you're gonna get x squared minus 2x squared. We can subtract them enough, but also subtract them. Right? We could subtract them just to eliminate the y by subtracting and get the equation at the same time. So let's subtract them. Let's call this equation 1, call this equation 2. We're gonna do 1 minus 2. Alright, so the 1 minus 2, the x squared minus nothing is x squared. And then the minus 2x is negative 4x. And then the 4 minus nothing is just 4 equals 0. And you want to know the nature of the root for this equation now. And this equation is going to solve to give you the 2 points, to give you, to tell you where the line and the curve intersect. So if this equation has 2 different roots, it means that they intersect at 2 points. If it has equal roots, it means that they intersect at 1 point. If this has no real roots, it means that they don't intersect at all. So we're calculating for this equation now. B squared minus 4AC. What is that equal to? It is equal to 4 squared minus 4 times 1 times 4 is equal to 0, which means b squared minus 4ac is equal to 0, means that we have equal roots. This equation has equal roots. I could factorize it and say that it has equal roots. But if I factorize it, it will become, x minus 2 squared, really, equals 0. So you see, getting repeated roots, so I get x equals 2. It intersects only at x equals 2. So it means that it's a tangent. So whenever we have to do this, it works itself out. Right? But by getting 0 there, it also means that it has equal roots, right? And if you have equal roots, the line that tangent to the curve. So it touches. So this only one that says touches. See, at x equals 2 here. And then after I get x equals 2, get the 2, put it back in this, to get the 4. So the answer is that one. Touches. Touches means tangent, and touches is a word you use when you have a tangent. Tangents touch. Tangents touch curves. So the answer is this one. C. All right, line that tangent. 2, 4. All right, that was interesting. That's an easy. This one now, give us parametric equations and I want the Cartesian equation. All we have to do is basically eliminate the t from those two. So from this one, I can make t the subject and the t becomes y minus 2. I can take the y minus 2 and substitute in the curve equation right there. All right, so let me leave it. We'll take this and substitute it for the t. Let me leave it on the screen. So I'm going to get x equals 3 plus 2 times y minus 2. Minus 2. So x equals this is 2y. And this is This time this is minus 4, 3 minus 4, negative 1. So what is it? This is the last one in this one. We transpose the 2y over here. I'm going to get x minus 2y equal negative 1. That's the last. Number 21. Given that the portion vector of P and Q are these, then what is the length of PQ? So we have to find PQ first. So PQ equals the difference between them. It becomes OQ minus OP, which is this minus that is negative 3. 4 minus a negative 1 becomes 4 plus 1 is 5. And then 4 minus 8 is negative 4. And then we want the length now. So that's the modulus. So the modulus of PQ becomes equal to 3 squared plus 5 squared plus 4 squared using this vector. All right, so that becomes 9 plus 25 plus 16. That's what it becomes. I left out the square root. Wow. Start to feel sleepy. Start to feel sleepy. Left off the square root sign. The length is Pythagoras' theorem. So it becomes the square root inside here. What is this inside this? What are we putting? 25 and 16 and 9. 25 and 16 and 9. 25 and 16 and 9. Root 50. Root 50. And put root 50, you're going to get this one. Because it becomes root of 25 times 2. Root of 25 is 5. And so it is all right. Lost my chain of thought there a bit. That's what it goes sometimes, especially at 1 a.m. in the morning when you want to sleep. All right, let's finish this. They give us this now, and they want to know which one of these this is the same one. So I say cot and tan. I prefer to just write this as cos over sine. I write this as sine over cos. So I'm going to write it as cos x over sine x. That's this one. And then I'm adding sine x over cos x. I want the two denominators to be the same. So I'm going to multiply this one by cos x over cos x. Multiply this one by sine x over sine x over sine x, right? Let's see what we get now. So we get cos squared plus sine squared. That's one in them. That's why I thought first. Cos squared x plus sine squared x over, this is sine x cos x. But when you use this product of sine x and cos x, you must be thinking about sine double angle. All I need is a 2 beside it. And we have a sine double angle. But this up here says 1. So this becomes 1 over sine x cos x. Always just want a 2 in front of that. I'm going to put the 2 here and the 2 up here. And this now becomes sine 2x. You have to know the identity. You have to know them. It becomes sine 2x. And sine 2x is 2 sine x cos x. It becomes 2 over the sine of 2x. This is the first hand sine was 1 over sine is cos x. This becomes 2 cos x 2x. That's it. All right, 22. 23 now. Let's get through this. All right. So sine 2 theta equals that. So it means that the pi by 6 is the principal angle. So starting out with 2 theta will be equal to pi by 6. But general solution you're doing. So if I do general solution, so let's take a color. 2 theta is going to be the principal angle first, which is pi by 6. And then pi minus pi by 6 for the second quadrant, plus 2n pi up here, and plus 2n pi here as well. And we're going to divide through by the 2, right? So the theta is going to be, it's going to become pi by 12, and it's going to become n pi. All right? And this one, no, this is really 5, this is really 5 pi by 6 and 5, because this is same as 6 over 6, right? So this is 5 pi by 6 and divided by 2 becomes 5 pi by 12 plus same thing again. Right? You divide this by the 2, you get n pi. So wherever that answer is, it is the answer. All right. So it is this one. We start to put the n pi from. That is it. Feeling sleepy. Let's finish this, Mr. Shaw. Let's finish this. All right, number 24. Or here. It says the vector u has a magnitude of 4 root 5 and is parallel to this vector. It says a unit vector parallel to u is what? No. Parallel vectors are the same unit vector. So the answer to that one is the unit vector of this. But the unit vector of u, the unit vector of u is equal to the unit vector of v, because they're parallel, right? Parallel. Right? The vector u has a magnitude and is parallel. Parallel vectors are the same unit vector. So the unit vector in direction of u becomes, what's the unit vector? 1 over the modulus. 1 over the modulus of v times v itself. Times v itself. So it's 1 over the modulus. 1 over 1 squared plus 2 squared. Square root of that. We can have the square root a second time. 1 over the square root of 1 squared plus 2 squared. That's from this. You don't need to put the minus, because negative squared, positive squared is the same thing, right? And you put back the vector, which is I minus 2j. What is record to? This is 4 and 1, 5. So 1 over root 5 times I minus 2j. 1 over root 5. Right here. All right, next one. It says two variables, the variable point P, X, Y, move so that it is the same distance from here and from here. The equation of the locus is obtained from which one of these? All right, so the distance from P, from what that means that XY, I'm gonna zoom it up. Let's zoom it up. So, all right. What it means is that XY 2, 1, 6 is the same as XY 2, 3, 2. These are equal distance. What is this distance? It is the square root of the difference in x squared, which is x minus 1 squared, plus the difference in y squared, which is y minus 6 squared. That is now equal to the distance between these 2 points, which again is the square root x minus 3 squared and y minus 2 squared. And let's see if I give that. Yes, they did right here. Easy question, easy. All right, next one, 26. It says a circle with this equation cuts a circle with this equation. So that's two equations. I'm solving two equations of circles simultaneously. First, you have to subtract them to find a common chord. Subtract them first to find the chord that is common to both of them. All right? Say, look at two distinct places. The equation of a common I. See, they're the one the equation of a common chord. You have to subtract them. So we'll call this equation 1. Call this equation 2. I can do 1 minus 2. So we'll do equation 1 minus equation 2. Let's concentrate now. What will happen is that these will wipe out each other. But then you're going to have -2 minus and -8. Minus minus becomes a plus. So it really becomes 8 minus 2. 8x minus 2. Minus 2 is 6x. So you're going to get 6x. And then you're going to have -6y minus a -8y. This minus minus again makes it a plus. So it's like 8y minus 6y is 2y. You get plus 2y. And then 1 minus 31 is -30. And then 0 minus 0 is a 0 on the next side. That can be divided through by 2. So we're going to get 3x plus y minus 15 equals 0. 3x plus y minus 15. This answer is this one. That is the common chord. Subtract them. Start after the subtract them. Find the common chord. I eliminate the x squared and the y squared. Cosine of the angle between these two vectors. Now, what are the two vectors? One vector is 1, -6. Another vector is 1, 1. Right? Remember, theta is the one cosine of the angle. Cos theta equals scalar product u dot v over modulus square modulus of u times the modulus of v. Right? So that's what we can create. So cos theta equals, how do the scalar product now? Multiply these two values up here, you get 1. Then multiply these two values, get -6 over modulus of u is the square root of 1 squared plus 6 squared. I call them u and v. Then now the modulus of v, using this as the v, is the square root of 1 squared plus 1 squared. So it becomes -5 over. This is root 37. And this is -6, 36 and 1, 37. And then this is 2. So it becomes the square root 37 times 2. 37 times 2 is how much? If I make a mistake, 37 times 2. I'm not seeing those answers. Make a mistake, man. It's not a 1, man. It's a 0. Man, this is 0. This is 0. Not 1, this is 0. There was no I. See? 0, -6, 0. Let's correct that now. So this is supposed to be a 0. 0 minus 6. And this right here says a 0. Instead of 1, you have a 0. Instead of 1, 6, you have a 0. So this modulus is just 6. You know? The vector is 0, -6, and modulus is just 6. I don't have to do no calculation here. This is just 6. 6. And you have root 2. So it works out nice now. The numerator is -6. And the denominator becomes 6 root 2. So they cancel and get -1 over root 2. The answer is A. And it's always good if you can find any mistakes. Nobody can make mistakes. Just finding it is another thing. Finding your mistakes. All right, next one. This one says the set of values of K, or with a straight line, intersect that curve at 2 distinct points. This is a question similar to up there. If it intersect at 2 distinct points, right? Then what will happen? We leave the question. So far, but it is Wow. So far, but still question with something or other like that. Anyway, all right, let's do this. Is somewhere there. Just something like whatever. So this equation now, these two equations, the lines that intersect the curve at two distinct points. So when you put the line and the curve together, like you solve them simultaneously, you're going to end up with a quadratic because there are two distinct points intersect. That quadratic must have real and different roots. And so the b squared minus 4ac for that equation must be greater than 0. First, I'm going to subtract the two equations. I'm going to subtract them. These two, subtract them. Like I'm solving them simultaneously, subtract. When I subtract them, I'm eliminating the y. So it's like I'm doing this one minus this one. Let's say 2 minus 1, right? So the x squared minus, not minus anything, give me back the x squared. Then the minus 2x and the minus kx gives me minus 2 plus kx. And then nothing minus the negative 4 gives me plus 4. And that is equal to 0. And I'm saying no, because that equation, the b squared minus 4ac is greater than 0 because we have two distinct roots. Because we have two distinct roots, two distinct points. The b squared minus 4ac of this equation that we're going to put must be greater than 0. And this is what we're solving. This is what we're trying to solve. That's what we're solving. Solve this. All right, let's work with the purple now. So the b squared is this. I don't put a negative by squaring it. So it becomes 2 plus k squared minus 4 times a. The a is 1 times c. The c is 4 greater than 0. That's a quadratic outside the roots, you know. Question is what are the roots? What are the roots? So it's under this. Well, this is the answer outside. But what are the roots? Can I find the roots quick enough? Roots. Because the answer is still like this root. The critical value. Right? Root of this inequality for the sketch and property. Is equals 0. So what will happen? If this is 16, right? You will get 2 plus k. 2 plus k equals plus or minus 4. When the carry this one becomes 16 and then you square root it, then you plus or minus 4. So based on that, we want k to be the subject, we want to carry away the 2. We carry away the 2, we want to actually minus it from the 4. So the k is going to be, make a mistake. All right, the k is going to be minus 4 minus 2 is negative 6. And also 4 minus 2 is 2. 4 negative 6. So if we were to sketch this with a k, it is like this. This is the k axis. One value is negative 6. One value is 2. And you went above the axis up here, which means that you're outside those two values. To the left of negative 6 and to the right of 2. So the answer is this one. 28, 29 now. 15 more to go. Coming up to 15 more to go. 112. This question says, given that A is that and B is that, then what is the modulus of 3A plus 2? If I find 3A plus 2B first. So 3A plus 2B is going to be, can I just work it out? 3 times this is negative 9. Right? Negative 9 and 2 times that is 4. Let's write that first. Negative 9 plus 4. And then 3 times is 21. 2 times that is negative 2. So it's 21 minus 2. So it becomes initially -5, and this is now 19. And then a modulus now. From the square root of 5 squared plus 19 squared. Square root of 5 squared plus 19 squared. And here just drop back in the calculator. I'm not gonna work it out. Why? And the calculator is right here. I want 5 squared plus 13 squared. Everything on the square times. So it's 5 squared plus not 13, 19 squared. 386, 386, 386. So this is the answer. Square root of 386. All right, that is that. Number 30. Remember, guys, if you're here so far, like, subscribe, share the video. And so other persons can get access to it and benefit from it. All right, this one says, path of an object is given parameter by those two. What is the slope at t equals pi by 4? So the slope is dy by dx, which is equal. So the dy, I'm going to differentiate this one to get the dy. Differentiate cos to get minus sine. I'm going to get minus sine t. As simple as that, over. You have a dt beside it, but dt. We don't need the dt, go and cancel. We never write the dt. So the dy equals this dt over. Because like you would have dy by dt equals that. I'm multiplying up the dt. All right? And then now, from this one, the dx equals the differential of this now. The differential of sine is cos. You're going to get cos of t dt. The dt is cancelled. Each other, bang, bang. That becomes tan of t. So this works out to be minus tan of t. But then it is pi by 4. So that's minus 1, minus the tan pi by 4, which is 45 degrees, which then becomes -1. -1. All right, number 31. All right, last 15 now. Let's move quickly through this last 15. So 15 and 15 minutes. Let's go. This one says we have to differentiate this twice. That's it. Let me give you an answer in terms of why. To differentiate the first time, let's zoom it up some more. We're going to get dy by dx firstly. That's a composite function. So we get 4 into 2x minus 1 cube. We'll differentiate what's inside and multiply it out here, which is 2. All right, so this becomes an 8 now. So so d2y by dx squared becomes, put the 8 first. I'm differentiating this now. So I'm going to multiply, differentiate this now. I'm going to get 3 into 2x minus 1, x minus 1 squared. And then differentiate what's inside the bracket out here with a 2. That's what we're working out in a second derivative. So keep the 4 times 2, 8 as a constant out here. So then I'm differentiating just this. Get this in the bracket. 3 times that, reduce the 4 by 1. All right, so this now is 6, 8, 48. So we get 48. This is the one answer with a 48, and it must be the answer. It becomes 48 times 2x minus 1 squared. Now, if y equals this, and then this is just a square compared to that, then the square root of this can turn this into a square now. The square with both sides. So it is the square root of y that becomes, so it becomes 48 root y, which is bang, that answer. All right, next question. The limit as x tends to -1 on this. Now what that means that when we factorize for this, because this means that x is not equal to -1. And so no matter what you say, it means that x is not equal to -1. So x plus 1 is not equal to 0. And there's no x plus 1 up there to factorize. So we're just plug in the -1. Let's apply the limit. And so it's going to become equal to, let me shake this down. That's up there. This becomes -1 squared is 1 minus the -1 plus -2. This is 2 minus 2, which is 0, and the numerator. This is -1 minus 1. It becomes 0 over -2, which is 0. Then it says 0 right here. 32, 33. Which are the following where the function has a point of discontinuity? So this inside is because of the perfect square, that is always greater than or equal to 9. Because the x squared can be negative enough. Right? So that expression is always greater than or equal to 9. The bracketed term, the term here. This one also is always positive. So its denominator value is always greater than or equal to 1. This can be negative. And then this is a linear function, so that's not a problem. This one now becomes discontinuous when the denominator equals 0. So the question is, can the denominator equal 0? This can equal 0 now, because you're starting at 1 and you're always adding something. So basically, you want to see if this can be equal to 0. So you're going to put x plus 1 squared equals 0. Square both sides are going to be when x equals -1. So yes, it can be 0. And so it has a point of discontinuity. You can't divide by 0. So this is the answer. This continues when x equals -1. So this is the one. All right? Because that's when the denominator becomes equal to 0. Next one. It says if a point A lies on this plane, then D is 1. It means I can substitute the points into the plane. So this becomes the x, y, and z. This becomes the x, the y, and the z. Plug into that. So when I plug that in, I'm going to get 3. So this becomes 3 minus 2 times -1, because the y is -1, plus 3 times the z, which is 2, that equals to d. And what is this? That's a minus minus. So it becomes 3 plus 2 plus 6 equals d. Therefore, d equals 11. Equals 11. All right. 34, 35 now. 35. Let's have a differentiate. I differentiate a quotient to start with the bottom and end with the bottom square. The dy by dx equals right on the bottom first, which is, let me shift this over. Dy by dx equals the bottom, which is 3 minus 4x. Then differentiate with top, we differentiate the top to get 1. You switch them around about your minus in between, the minus the top. Then differentiate the bottom, differentiate the bottom, you get -4. All over the bottom square, this diameter squared. 3 minus 4x squared. Consolidate the values now. Careful the negative signs here and here and here. Careful. All right, watch this now. Expand this first with the one that comes back as is 3 minus 4x. It's like the minus becomes a plus. So like you're doing 4 times this. Am I right? It's like you're doing 4 times the bracketed term. Plus 4 times the bracketed term. Right? Like you're doing that. So 4 times 6 is 4 times x is 4x. And remember, it's a plus 4 multiplied with this minus gives you a plus, right? So that's it. Give me a plus 4. This and this. Give me this plus 4. So I'm going to get, this is that. I'm going to get 4 times the bracketed term here, give me 4x minus 24 all over 3 minus 4x all squared. So these two approach each other, and you have 3 minus 21, 24 is negative 21. So it become negative 21 over 3 minus 4x all squared. And looking for that, minus 21 and minus 21. So the answer is A. My eyes went to this quickly. Yeah, now you know negative 35. 10 to go. 10 to go. So the volume of a solid generated when the area enclosed by the curve y equals x squared in 0, y-axis is x equals 0, and 4 is what? All right, number of volume. Let's zoom it up again. Let's zoom it up, try to find the volume. So the volume, remember now, is 5 times the integral y squared dx. So this one becomes 5 times the integral. What are the intervals again? 0 and 4 is y around the y-axis. Wow, 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 wow. So it's x squared dy. See, read carefully. X squared dy. Man, x squared dy is around the y-axis. This show me now. I say y plus 4. It has to be x something. All right, so the x squared is just y, you know. Man, x squared is just y. This becomes the integral of y dy between 0 and 4. Almost gave it away. I said, greatest thing is to be able to catch yourself. Y squared over 2 between 4 and 0. Again, before we get 16 over 2 is 8. So the volume is plus 8 pi. It says 8. Almost gave it away. I can bet the answer would be there now. Catch myself. Curve is defined by the equation. Given that x increases at a rate of 1 unit per second. So that x increases at a rate of 1 unit per second. That's dx by dt. Let's give us a dx by dt is 1. What is the corresponding rate of increase of y? This is asking us for is dy by dt, you know. We don't have any formula connecting y and t, so we set up a chain rule. We have to differentiate this. All right, so we'll get dy by dt equals the product, two rates of change. Dy goes on the top of the first fraction, dt goes on the diameter of the second fraction. dt. The third variable is x, dx. Right? So we're going to differentiate y now, right there. So, and it says when x equals 1, right? We're going to differentiate the y up here. We're going to get, that's right, we're going to get minus 10 bracket 1 minus 2x. And we multiply our differential what's inside, which is minus 1 times dx by dt. They tell us right here is 1. 1 times 1. That's what we're working out. And when x equals 1, right? So let's write it. When x equals 1, the dy by dt becomes this minus make that a plus. So we get 10 bracket 1 minus 2 times 1. That's what we're working out. That's what negative 10, negative 20. That's right. Inside not there that way, so made a mistake. Oh, see mistake here, so it's supposed to be 2. Differentiate here, so we got 2. Differentiate what's inside the bracket. Sleep. More sleeping. Sleep. I want to sleep. Sleep. I want to sleep. Let's check it again. I'm differentiating this up here. So I'm get negative 10. Was reduced by 1 over 4 of 1. The multiply by differential constant bracket. Okay. Then now multiply by this. So put times, and this is 1. Right, so this actually now becomes 20, positive 20, not a 10, right? It's 20. And so it becomes 20 times minus 1 negative 20. Right there. Come on, come on, come on. 8 to go, 8 to go. Let's finish those 8 quick and fast. It says curve C has this equation. What? Stationary point. Stationary point, we have to differentiate and put dy by dx equals 0. So let's zoom up on it now. So when differentiate this is the same as 16x plus x to the minus 1. So dy by dx is 16. You're going to get minus x to the negative 2. So that is equal to 16 minus 1 over x squared. And I put this equals 0 at the stationary point. Right? The stationary point is equal to 0. 0 by dx is 0. So solving this for x, right? So when I go to 4 and for some minus a 4, that looks like, you know, I'm going to transpose this over here and get 1 over x squared equals 16. Multiply by x squared and divide by 16, I'm going to get x squared equals 1 over 16. I'm going to square both sides. X is going to be plus or minus 1 over 4. Bang, right there. Now, no hesitation, 39. You want us to just differentiate that. Product rule. Product rule. Let's zoom it up. You want to keep the first and differentiate the second. Keep the first equals. Keep the first, which is x cubed. Differentiate the sin x to get cos x. Plus, keep the second, which is the sin x. And differentiate the first. First is 3x squared times the sin x. I just need to factorize that x squared now. So I'm going to get x squared out of this, going to live with x cos x. And down here, I'm left with 3 sin x plus 3 sin x. So x cos x, 3 sin x, x cos x, 3 sin x, x cos x, 3 sin x. The answer is right here. 3940. This one now, give us this and want us to write that out, right? So I'm going to make this a subject first. That one. So that I could carry the 1, add it, and then divide 2 by 2. So from this now, the cos from this, the cos squared x, which what we see here, similar function is divided by the 2, you know, divided by the 2. So basically the 1 will go over first and become 1. Divided by 2, you're going to get half. Then it's going to be plus half cos 2x. All right. So if it, okay, so remember x over 4. So I'm going to do to do the x over 4 is put x over 4 on this. Do 4 x as well. So this with x over 4 becomes equal to half plus half cos. It's going to be x over 2. 2 over 4 is x over 2. So if I'm integrating this, I'm also integrating that. So I can put integral on it now. So integral of this with respect to x, I'm going to integral of everything here with respect to x. And the integral of half is half x. And you're adding back this half the integral of cos x over 2 dx. So that answer is here. All right. And then we integrate this part, so that they will put the C in. After integrate this, you can put the C. Number, this one now. It says the gradient of the normal to this curve at x equals 2. All right, so we need dy by dx. All right, gradient of the normal we want of this function. All right, so the gradient of the tangent is dy by dx. Gradient of the tangent is dy by dx. How do you differentiate ln? Differentiate the x, you get 1, put it back over itself. Put it back over itself. Differentiate the x and put it back over itself. That's the gradient of a tangent. You know? The gradient of the normal is what I want. Is minus 1 over the gradient of a tangent. Which then, if you flip this and change this, you're going to get minus x. So this is like the function for the gradient of the normal. So x equals 2. So x equals 2. The gradient of the normal become negative 2. Size A. Right, 41. All right, and 40 is now 42. The rate of a circle is increasing. The rate of a circle is the rate of 0.1. That's dr by dt. Connected to the rate of change is 0.1. At the instant when the radius is 3, so when r equals 3, the rate of increase of the area, the one dA by dt, that equal the product of two rates of change again. dA goes on top of the first one, dt goes on the bottom of the second one. Third variable here is r, dr. This is 0.1 and no. What is, how do we get dA by dr? We get dA by dr because we have a circle where the area is pi r squared. So it means then that dA by dr is equal to 2 pi r. So 2 pi is coming right there. So we're going to get 2 pi r times 0.1. Remember the r is 3, right? So it's going to become 2 pi 3 times 0.1 is 1 over 10, which is 3 over 5. 3 over 5 pi. So 5 pi. So, all right. Just give me that. That's number 3 to go. I want to finish on this page. They will finish on this page. It says if the rate of change of y with respect to x, that's dy by dx. It tells us that this is dy by dx. Dy by dx is telling us it's 3x squared. Let's put it as plus 4x to minus 3. Then y, what is we have to integrate to get y? So y equals the integral of 3x squared plus 4tx to minus 3 dx. So integrating now, it's going to give us x cubed. And then I'm going to add 1 to this for 1, get negative 2. So we're going to get 4x to the minus 2 divided by the new power of negative 2 and you add by the c. So it's going to be x cubed. It's going to mean that it's minus, that will become a minus 2 over x squared. Looking for that, looking for that, looking for that. Plus c. Plus c. Plus c. Just double checking, guys. When I differentiate these, I'm supposed to get about that, you know. So sometimes I can double check that. Bang, bang. Yep. Yep. All right. So the answer is x cubed plus 2 over x squared minus 2 over x squared plus c. x cubed, right? For the 4 now. It says the limit as extend to that of this now. So we factorize this, right? Because on this one node x cannot be equal to 0. The x not 2, x cannot equal 2, so x minus 2 not equal to 0. We have to factorize x minus 2 because it can equal 0. So we can cancel out. That's the difference of 2 powers, right? So the fact that it becomes the limit, and then zoom it up here. The limit as x tends to 2. That's the difference of 2 powers, which becomes x minus 2 times x squared plus x times 2, which is 2x, plus x cubed, no, 2 cubed, right? 2 cubed, 2 cubed, 2 squared, sorry, 2 squared, 2 times 2. That's what we factorize the difference of 2 cubed and then divide by x minus 2. Then now these cancel each other. This cancel that, and so left with this in the bracket. So what we're gonna do with it is to apply the limit of 2. So I apply the limit of 2, I get 2 squared plus 2 times 2 plus 2 squared. That's 12. 12. It's question 45. Last one. Yes. Yes. I do 139. All right, let's finish this. All right, it says the gradient of the normal to the curve at x equal 1 is normal 1. So the gradient of a tangent again. We got question like this, so what again? The of a tangent is dy by dx on the curve, which is this becomes 6x minus 2. You can find the gradient of a tangent by plugging the 1 in the book. We could also get an equation for the gradient of the normal. So the gradient of the normal is minus 1 over the gradient of a tangent. So flipping this and changing the sign. This is x minus 2. So I'm going to flip it and change the sign. We get minus 1 over 6x minus 2. It's gradient of the normal. So at x equals 1, gradient of the normal becomes minus 1 over 6 times x equals 1 times 1 minus 2. So becomes minus 1 over 4. And that is that. Yep. So if I put the 1 in here, so what I get 4 for the gradient of a tangent. The gradient of a normal is minus 1 over 4. So it could be that way as well. That is it, guys. That is it. So remember, if you like the content of this video, you share that like by clicking the like. You can subscribe. You want to see other videos are posted. All right, and you can make a comment. The general approach to this paper, how we can maybe improve. Just any comment. All right, any comment will do, and be sure to share. And I teach math and maths, CSEP maths, pure maths, and my number is 881-5600, area code 876, and I am graphic show, as you see on the channel. My middle initial is key, so see that key there. That's my name, graphic show. All right, so let me know what you think, please. Let me know what you think in the comment section, and like and share. And if you would like to get other videos, future, we'll post new videos, then you can subscribe. If not, that's fine. Just leave a like and a comment. All right. Okay. Good night. I'm gonna end it now. All right, Mr. Jordan. So I did this one for you. I'm sharing with the world. All right. Sharing with the world. So each time I do a video, I'm gonna post it. I'm gonna post it in this channel for everybody.